we have this contract. It's just a safe, or you can think about it like a vault. You add some ETH into it, and it adds balances according to whatever value you've added. You deposit it in that contract using the receive. It's a fallback basically. This is like with technically. Uh, and then you need to withdraw all your balance back. So you have your own balance that is recorded already in this mapping. And it's going to be, of course, reset to 0. And then you're going to take back the ETH that you deposited to that contract. It's very simple, but right now we're gonna do some fuzz testing on it. And by the way, this is just a startup because this is actually the example in the Foundry documentation. So you can find that if you go to Foundry and you go to advanced testing and then you go to the fuzz testing section, you will find that example exactly. So, so we start off like just writing normal, like you're approaching like a normal unit test. So I'm going to be testing withdraw here, function, test, withdraw. I think everybody here is familiar with Foundry. Like I know most of us already worked with hard hats, but I assume like also all of us are familiar with Foundry. Anybody here not familiar with Foundry? Using Foundry? Okay. So that's good actually. So in Foundry, basically, if you want to write a test, you just write the function and you precede it by the word test. So that's why I'm writing it like test. And then you can name it any name here. And Foundry, while you're doing the test, it will already pick up and it will figure out that what you're writing here is a test that should be run in the Foundry test runtime. So I'm already having Copilot, so it writes it for me. But so I would just write it here anyway. So what I'm doing here is just I'm gonna test the withdraw function. That wants Copilot to do that for me. So in order to withdraw, I need first to send something to it, just a normal unit test. Needs to be payable. Okay. So I will run that first. So what's gonna be doing here is gonna have an amount of 100, and then it transfer that 100 way. Is it 100 way, not 100 ETH? You know the dominations, and then it transfers that 100 way to the safe contract that is created here, which is the contract we're testing. It's like basically like red ether, and then it's gonna withdraw that. So we are expecting after that to have the balance to increase by 100. You know what? I'm gonna write it right now, just making sure it doesn't revert, and then check out uh, uh, you know, the balances of the volts here of that tester. Okay, so push test. Okay, in order to debug that, I need to increase the verbosity. Oh, okay, okay. Okay, that's out of gas. I'm sorry, guys. Like I mess up sometimes. Okay, so uh, what's going on here is I am I'm basically having this transfer here. I'm transferring that amount to the safe. The safe contract is here. It takes the ETH. There's no issue. And then I got sorry, I don't know what's going on with this case. Okay, I'm gonna just use Wolf. I think value amount. Two. I did this. I think the current contract doesn't have enough amount to send, so it's because to reboot, I think. I well, yeah, this safe test contract doesn't have enough amount, so I think it's because it should be having it by default actually. I think start for 10 would be 2300 gas. It is just enough to like yeah, it was just a call. Yeah, it was just a call. I'm sorry. I'm really sorry. It was just using the call transfer whatnot. Yeah. You know, like what's the problem is I'm very silly. You know the problem here? When you use transfer, you have only 23,000. That's actually what you said. And that's only enough to emit events. And this is like a very beginner mistake I shouldn't have done. But yeah, it's sometimes you forget about this. Technically, you use call, you don't use transfer or send. I'm just using transfer when I don't to avoid reentrancy. Okay, anyway, this is just a normal unit test. But what I want to do right here is I'm gonna check in that unit test. I'm gonna check the balance. I'm gonna create. I'm gonna check the balance of the contract of the tester contract before, and then I'm checking the balance of that tester contract after. So, and what I'm expecting is that the balance should be increasing by the amount that I'm gonna be withdrawing. So this is just a simple thing, but didn't just getting started. Okay. So yeah, we have here the situation here, like yeah. Okay. So the initial balance here, sorry, I should be actually like testing during the action itself, not testing here. So the action is going on with the withdraw function. So here I'm testing the withdraw function. So I'm testing the balance by 100, which is the amount. Yeah. So right now it succeeds. So what fuzzing should do for us here, like all this time I'm checking that with a fixed amount. That amount is just 100 way, but I want actually to be able to test like a limited, like a countless amount, a countless number of different values of amounts. So this is very very easy in Foundry because you just come here and add this amount to the argument of the test, and from here this value is just and this value is just going to be random, and the tester itself is going to be the agent that actually feeds this amount to the feeds this value to the test. So if you do that, actually, I'm going to expect some error, but it will run at the beginning, because the cool thing about fuzzing, you have a number of runs here. You can configure that here. So here. It's gonna be running that test supposedly like about 256 times. So it's gonna call that 256 times with different values of amount. So what we see now, it's gonna be running like for some amount of time, and it's gonna be fail for some reason. But this time I'm gonna know why it failed actually, and I'm gonna show you what. So let's take a look together. I'm gonna do it like this so that it shows better. Okay. So, what happens here? And it's just to show you the runs. Yeah. So it tells you here, it runs for 50 times. These are parameters I'm going to talk about for that, but I'm just concerned about this runs. It runs 50 times and it shows us some assertion failure here. So what do you expect? Like it should be running actually, as I told you, 256 times, but it kind of failed midway. So why do you expect this happens? As I told you, amount is going to be very random. It's going to be random. Like it can be 100, it can be 1 million, it can be 10 to the power 18, it can be 10 to the power 200, whatever, like 70, the maximum, I guess. It can be 2 to the power 128. Like, and the tester contract, I want to send 2 to the power 100 to the safe. You better be having that 2 to the power 100 first. But actually you don't, because at the rule here, when you start the test in Foundry, that you have is 2 to the power 96. So what we want to do is actually to limit that amount while you are doing the test to be less than 2 to the power 96. And I'm going to do it by vm.assume. So let me just do it here. Less than 5. I'm going to explain what assume is doing here. Okay. So what assume is doing here, it makes like if for example you have 2 to the power 100, the tester feeds some 2 to the power 100 into the test, it's gonna basically reject that value. So it's gonna reject and run again with a newer value. Pick up another random value for amount and run it again. So this is actually what we want to do for now. By the way, it's not perfect, but we're gonna do it this way for now. And we can find actually other better solutions here. So now it runs successful with no problems because I limited to the to that value exactly. So you can notice here the runs are 265, right? But we had a bound which is 256. Actually, these are like the rejected tests. As I told you, like it's gonna run the test, and vm.assume is gonna reject that because the amount is not less than the maximum amount that I set. So it's gonna run it again until it gets a proper value. Okay, so everything is clear to now. I think like everything is simple. Starting off very easy. Okay. So I will make a change. I will add some more feature for the test, because right now what I'm doing here is that I am taking that withdraw that I'm with that save in a way that the only message that senders, the caller of that function, when I go to save and you have here message to sender, it's gonna be always equal to the address of the test itself, the safe test. And this is not very practical. So we want our contract to be interacting with all kind of addresses, like all kind of actors. It can be interacting with a contract, can be interacting with externally on the address or whatever. So I'm gonna do something here. I'm gonna add another parameter. For now, I'm gonna call it an address. Okay. And call it account. So right now, it's going to be a random here. So in order to like make that account send be the caller of the withdraw function, we need to write here the cheat codes of Foundry. It's weird because of course we can't do that in reality, but yeah. So gonna be start crank. Okay, account. And after calling that, we're gonna end it here. Gonna stop. Okay. And while I'm checking the balance, I'm gonna be checking full for the account itself. Not the pounds. Okay. Okay. So this time I'm doing that with a random account. The balance and the pre-balance before we draw. Okay. Sorry, this is the VM. Okay. I'm gonna run that. You can be praying that it works, but actually it will not work. But I just wanna show you why we do that and because of the next step. So right here, the new thing I'm trying to do is I'm trying to fuzz the address itself. And I'll show you why fuzzing addresses is not very practical in here. So it tells you it fails. And right from the first run, it didn't like it. Okay, but I want to read how this actually works. So what it says here, well, we had some assertion failure, and this assertion failures, the thing I'm interested to be focusing on is actually the arguments here. So what are these arguments? Because when you are fuzzing, you're gonna see this a lot. So what are these arguments? These arguments are the arguments of test. So it tells you when I called, when the tester called that test withdraw function with the argument of zero address and amount one, it failed. And you would expect, yeah, it should have failed if the address is zero. And it failed actually because the address zero doesn't have any is to send to the caller or whatever it is. So you need to be careful about the addressees in general that are sending this account. And I will try to fix that. I'll try just to act and like, okay, we don't want address zero to be making these kind of calls. So what I'll do here is, okay, assume and by the way, of course, like not all addresses is gonna be having that 2 to the power 96 is. So actually that's something we need to be watching out for. Okay. I'm gonna do here. So it should be running few more runs I'm expecting. Let's see. Yeah. So it runs here. I want to show you just like how things are going on, because actually when you face these errors, it's better to deal with these errors together uh, rather than like having to deal with these errors alone. And I'm going to show you how to overcome these and why actually these errors are there. So here it runs like 34 runs more. And it got stuck. So we take a look. It's going to be telling you like, these are the arguments. This is the address. I expected it failed actually for another reason, but okay, whatever. This is the address, and this is the amount. So if you take a look carefully, you're going to be finding that this address is the address of the VM itself. And this is not good, basically you don't want, like, these are like kind of the artifacts that Foundry are using in order to do tests. Like, there are several things. If you check out how Foundry components are going on, there is a component like the deployer itself uh, uh, does the cheat codes, does the console, does the stop rank, or all the kind of
I think we lost you.
to be in the fuzzing view. Oh, sorry.
Yeah, could you repeat latest sentence sometimes?
Yeah. Okay. So can you listen to me, guys, right now?
Yes.
Yeah. Okay. So this is something really important because you might get stuck with it. When you are dealing with addresses, we are dealing with fuzzy addresses. You can be picking up any address in that kind of ecosystem. So while you're in Foundry environment, you have a lot of components that are actually Foundry specific. I need to get in details. Is the VM? Is this special, like, this VM is actually something in Foundry, like some contracts interact with. It has some special, of course, some special roles, but we are not interested to interact with it. And there is something else, like there are also precompiles, something also called precompiles from 1 to 9. You don't want to interact with this either. So I'm going around, but actually what I want to do is, don't try when you are fuzzing address, you be careful. But when you are trying to do that, it's better to build your own addresses. These are like the externally owned wallets or whatever. And then you try to, you try to fuzz these addresses. I mean, like you try to make these addresses the accounts you are dealing with. So how I'm gonna do that? This is another question. So I'm gonna say, like, for example, hey, let's assume that accounts is equals to, we have here boss, Alice, and Bob. So it must be equal to Alice, or it must be equal to Bob, or it must be equal to boss. Like, let's just try. Maybe it works. Okay. I told you that assume is magical. So it's gonna be working like that. So that's another error. You might see it a lot. Assume is giving you a lot of power. Remember how I told you assume is working? Assume is working by you have your when you are testing, you are generating random variables, and assume is telling you, well, if these values are not the values that I'm trying to assume, that I'm trying to work with, I'm gonna reject it. So what happens here, because you are limiting it to very specific constants, you are actually rejecting too many inputs. So assume is good, but don't try to abuse it. So basically you need to deal with it in another way. So somebody can have a solution how we can deal with it. Like, is there something else we can use instead of assume?
Can be used bound functions.
Yes. I believe people already know how to fuzz. So yeah, that's exactly actually what's going on here. So what is he saying here? We're gonna use bound, which is basically, I'm telling the fuzzer, hey, I want you to choose random values, but this random values has to be one of these three. false or else or pop or whatever. You need to increase your inputs, of course, and that's not very generalizing, but this is just for the sake of example. So what I'm gonna do here in order to be using receives only in the array. Okay. So I'm gonna replace the account by an account because right now I want to map to elements of array. So I'm interested in values like 0, like 1, like 2. I'm not gonna be interested in the address itself. And I'm going to delete I'm going to delete that assume. I don't want it. And I'll replace it by account index bound. So what is it about bound here? Bound is, if you try to see where it is, it's in the standard utils of the test itself of Foundry. So this is function in the test when you inherit the test construct of Foundry. You're using these functions by default, so you don't need to do anything. These functions are available for you, among a lot of other functions. So what it's doing is here, like whatever value is in account index. Account index, remember, it can be anything. Like it's a uint 156. It can be 2 to the power 56, basically -1. So it can be anything. So what I'm telling you, whatever value is here, I want it to be bound between 0 and the length of accounts -1, which is between 0 and 2. So it either can be 0 or 1 or 2. And this is a new value right now. So the value of bound and right now here accounts is gonna be equal to accounts with the accounts index. So I think everything is clear, right? Everything is fine. Okay, so let's run this because after that we're gonna move to another one. Oh, sorry. I did build here. Okay. Not sure. Okay, yeah. So right now I'm basically limiting all my options to these accounts, and there should be no error. This is not very good generalization because some of the accounts can be contracts. So, but right now, like you just assume like, hey, I'm dealing with externally owned accounts. Okay, so we can only go forward right now. I can check my notes, please. Okay. Something else here I want to talk about, which is fixtures. I told you that the fuzzer is choosing some random values, values for the arguments which you're testing. But these random variables can be literally anything. And you have limited number of runs. You have like, I'm limiting it here to 256. But for example, I want to, I want to tell the fuzzer, hey, there are some values I want you to take care of. I want you to consider in your this kind of random sampling that you're doing. So you need to give it like some keywords about it. Okay, so how do you do this? There is something here like called fixtures. So that's basically what you're gonna do, and it's very, very simple. What I will do is, let me get the fixture here, UN256. So I want, for example, this amount to have some value. to be included in the test, and we'll know how we include it. So amount, because it's named amount, but before the word amount, I'm gonna say fixture. It's like really like magic string. This is how Foundry is picking up this thing. So I'm gonna call it here like fixture. Fixture amount. And this is an array. I'm gonna give it like some values here. Right now we will not know what, but let's see together. Okay, so it runs no problem. We don't know for a fact if it actually picked 300 or picks 200 or picks 100. But I'm gonna figure it out. I'm gonna know how if it did it or not by actually forcing it to fail if it picked these values. So what I'm gonna do here, after I take that amount here, I'm gonna make it require that amount. For example, I'm gonna say not equal to 199 divided by 3 plus 3, for example. So this is 333 plus 3, which is 336. So what I'm saying here, if you pick the amount of 336, you're gonna fail because you're not actually you're not actually like gonna be passing that required statement. So I'm gonna do it here. I want him to pick that amount. You see, I'm just using magic numbers right now to just show you that he's picking the fixtures that I'm giving to him. So that indeed what happened here. You can see now, because of that magic fixture string, using that in the test, right? This is 336. As I told you, like these arguments are what shows you which test has failed. So it took 105 runs in order to figure out when you use that magic numbers, 336, you actually fail. And how did it know about to use 336? Because I gave it to the fuzzer, 336 here. So is that clear? So we are good. But I will have a question right now, okay? If you think you understand this part. Why do you think I did that, all this mess to say 336? Like I did it like nah, by 3 plus 3. Why did I do that? Why didn't I just write 336? Like assume I'm not using fixtures. And I write a number like this. Amount is not equal to 336. What do you think is going to happen? Like most likely, if you have a big number of fronts. Okay. Something cool about Foundry and also Echidna, and I think Echidna is better in this. It's like the word smart fuzzing, I think, is that actually it cheats. Like it looks at these magic numbers. It doesn't, I told you like it generates some random numbers in order to give it to the fuzzer and start the tests. But it also has a source code, and maybe it can figure out, what this is 336. Okay, I'm gonna put it also. It's in my dictionary, and I'm gonna use it to put it in amount. So sometimes actually this happens, like actually most of the time. So it picks up these numbers, these magic numbers from your own code, and it feeds it as a random number. So if you just write it like that, it will actually pick it without even using a fixture, basically. So I have to like make a roundabout about way actually to figure out, hey, maybe I need to write some mathematical formula that the computer will not figure out, and it will not, the father will not figure out, and it will not edit to the amount. So that's it for just the first part. So is everything clear?
I have one
Is there any question? Yes, please.
yeah. So is there a situation where the runs are so less that the fixture amount do not cover all the values?
The fixture amount will not cover all the values. What do you mean?
Yeah, so like there are limited number of runs. So let's say it runs for 256 times and it does not cover all the values from the fixture amount array.
Yes, I think it can happen. For example, you see this, it didn't use 336 until I come to the 105th run. So yeah, that's why I said like maybe you need actually to do more runs.
Yeah. So is there any way to like uh, prevent this? As we have a large number of values in fixture amounts array, and we are running for some.
So you were saying, Sumit, please, may you say your question again? Somehow I lost you.
Yeah. So let's say the array fixture amount array is so big, so that it does not get covered by all the 65,000 runs by the fuzzy. So
Yes, you will definitely need a lot of runs. Yeah, you will definitely need a lot of runs, but you will not write, you will not put a lot in your fixture. You basically need some special values. I don't know. I didn't see project people putting a lot of numbers in the fixture. Yeah, but yeah. I get it. It's a very good question, really, because I read the docs. I actually don't see if you can know that all the fixtures are used or not. There is something else that you can do in Foundry, which is the coverage. But how the sampling is done and how you know like the sample values that are being used, I really didn't see that. But I think you can be safe. You typically actually you know, and I will show you a project I when I was writing test, I actually did fast test instead of testing. And when I was using about like 4096 or something like that. You don't actually use 256 or these low numbers. Usually I use numbers like low numbers of runs when I'm just, you know, writing tests and I'm just checking my code, checking my tests are actually working. So, you know, you run a lot and it takes time. So you need like something less, like 100 runs or whatever. And then when you actually run for coverage, you choose like in the order of thousands. Like, like I used 50,000 even. So yeah, I don't think like, for example, you were having here like a fixture array of 50,000 elements. So you just need to have like a number of runs that's in order of thousands or something. I think this is a safe number. You're welcome. Okay, so that's it like for this part. I want to show you some exercise. Okay, here. Um, I will send it to the workshop channel. Okay, so just talk about it quickly. It's just an ERC20 token. Okay, but there's something buggy in that ERC20 token here. And I will give you a hint. The bug actually is in the transfer function. And if you don't actually find that bug, it's actually you know, very it's very noticeable by the file. So you already created a Forge, you already created a Foundry account, Foundry story project. So you just add this to the source and have a test here at an ERC20 test. I will give you like 10 minutes and we still have like 15 minutes after that because there's something really quick I want to explain, which is important for coverage.
So is it something we will just wait 10 minutes until the team is trying to resolve the case?
You can do it actually in 7 minutes, guys.
Okay, so
Yeah.
researchers will be much involved there. We have also our sales team on the call, Gustavo and Marta, and also it will be useful for myself. Would it be possible for you to tell, like, maybe in general, some tips or what's really useful to communicate with clients while maybe selling or talking about fuzzing? What's some like high level and easy things we should mention while talking to clients about the service, about the actually about the use of it, yeah, why it's useful, where it can help, or where it's not needed. So maybe some general overview.
Yes, indeed. Okay. Actually, okay. Just hold that test, guys. Just hold that exercise. I will go to the second part. Bear with me. This is a project. It's just, I believe, Relais protocol, which we call here Nakama in our Slack. I actually did it by fuzzing, and I will show you what can be done here. So what's good about fuzzing here? So yeah, Relais protocol. Okay. It's 128, but actually when I was running it for coverage, I used like, and I will show you like why actually I use 4,000 number like that and what impact it can happen. So this is a project I wrote the tests in it. The fuzzing, you can see like there's a lot of lines of code here. The cool thing about fuzzing, you can see like I'm mixing actually unit tests with fuzz tests. Usually you see like in documentation, people tell you if you want to do fuzz, you just write test fuzz, but actually this is not required. You do test fuzz just for yourself to know that this is the fuzz test, but it is automatically fuzz test if you had arguments to the test. It's like that. What I want to show you, like what fuzzing can do, is basically to increase coverage that you will not usually see without fuzzing. So I will just show you here the coverage. I'll tell you later how actually to show coverage of fuzzing. So I will open it with a live server. Okay. I will tell you how to generate these things actually later. Okay, so this is the source.
The screen is not showing the Nakama.
Oh, sorry. Yeah. Thank you for should I present the entire screen right now? Just bear with me. Okay. So I moved from presenting my VS Code all to the entire screen. So what I want to show you here is like how to actually generate coverage with your fuzzing. I will just show you something, what fuzzing actually does to you. And then I'll show you the how to actually generate these kind of things. So let me show you, for example, if I run for IRA here, I will show you, like, for example, if I run that coverage, let me remember the command. Right now, the coverage runs are actually set on 256. So this is a low number. And you remember here, I want you to remember the amount of coverage I'm having here. Let me check. Okay, so I'm having about, just forget about this. This is not actually in our scope. So we have about here, line coverage is 97.9%, and 96.4. These are the numbers. I'm gonna take these numbers and regenerate them again. So you do coverage, report, alcohol. This is gonna generate a file that is called the elcov.info. This is basically a big file that actually shows you what you are hitting, and it gives a lot of information. But of course, you cannot visualize that thing. You cannot make any use of it. So in order to interact with it, I will have another tool called genHTML, generate an HTML out of this file. By the way, I have notes for you for all these, so don't worry about it. I think I better clean the coverage better before I do this. It should work, overwrite it, but I just do it for the sake of cleanliness. Okay. So I'm running the coverage again and checking out what's going on here. So you can see here something is noticeable here. Because I choose less runs, I actually hit much, much lower coverage. And by the way, I didn't change the test. Like this is literally the same test, the same fuzzing test, but right now is lower coverage, but changing only one parameter, which is runs. So what happens here is, because you have less runs, it means you're having less random values that you are injecting into your test. It means that you're not covering much of the code. When I use, for example, 4096, I'm going to be covering more. I'm going to be introducing more random values, and I'm going to be covering more. And guess what? When I do that, sometimes I actually find some failures, some assertion failures that actually show me there might be an issue going on. When you run, of course, more runs. So imagine you have one run. One run is basically the unit test. It will cover almost, like maybe 50% or whatever. It will cover nothing. Like it doesn't cover anything important. So basically, you increase the number of runs, which is fast testing. You have more fast testing. You have more coverage. You actually can find something like edge cases. Like here, like he talk about the edge cases. You can find edge cases that that cause errors that you might not be able to find while doing something, some other manual review or normal code review without testing. And this is actually the example that the exercise that I wanted to give to you. It's some actually edge case that you can discover by fuzzing. So yeah, you can say like fuzzing. When you are fuzzing, you are having you are showing more code coverage. You can actually discover edge cases that cause errors. So yeah, I think these are good good points for saying that. So let's run, like, for example, 4,000. Of course, when you add the runs, you consume your CPU. If you have a better CPU, you're gonna have. Oh, sorry, like I shouldn't do this. I'm gonna run force coverage. Gonna generate the L coverage report. It's gonna take time. Actually, by the way, like while I'm doing that test, I have, when I do more runs, yes, I can see assertion errors, some failures, but these failures, like I go through it and I discover actually it's not something worthy to mention. So yeah, this is actually a living example. Like because I add more runs, I actually see my code, my test fail because it generates arguments here, random arguments here that actually shows you something is wrong and you need to take a look at it. Okay. Should have more tests than this. Yeah. You see, because I'm having 8,000, it's still running. I told you like it's gonna take some time, but I want to show you like how significant is this with coverage here. Oh yeah, now it works. Okay. So Ira, does this answer the question? I can actually go and create I know some document that actually can speak about the benefits of fuzzing like in a more like formal way, and I will write it here.
Yeah.
But you see now this is in front of you, like you see like it was 81% coverage, right now it's 98% coverage, and this is, I didn't change anything of the code that I write for the test. And it means like less codes, you can have a bigger project, a bigger code base, but you are generating more values, that it makes you basically what happens is you cover more branches. Like you have some if statements here, you are covering them because you generate more values that gonna make you hit more code with the same code base and test that you write. And what's more important as well is the edge cases, which is exercise I'm gonna go to. Okay. So yeah, let's go back to the exercise. Is there any question about how we actually visualize coverage in Foundry fuzzing? I think some people already know how to do it. Took me some time to figure it out, but I think it's I think it's gonna be easy once you find out how to do it.